everyone. It's a pleasure to welcome you all to yet another insightful session of the Glass Academy webinars in association with Ethos Empowers. We are thrilled to have you all here as we continue to explore the ever evolving intersections of architecture, materials, sustainability, and innovation. Today's session, titled High Performance Glass Facades for Safe and Future Ready Architecture, dives into projects that are not only designed with aesthetic brilliance and functionality in mind, but also grounded in research backed disaster resilience strategies from natural challenges like climate extremes to man made conditions. At the heart of these buildings lies the purposeful use of high performance glass as a solution that addresses energy, safety, and longevity, all without compromising on design integrity. To guide us through this journey, we are honored to welcome architect Rahul Kadam, an architect whose career and design ethos truly embody this theme. An alumnus of BKPS College of Architecture, Pune, and a master's graduate from South Bank University, London, architect Rahul Kadam has worked with some of India's most renowned architects, including Bimal Patel, Hasmukh Patel, Kamal Malik, and Karan Grover. He spent over 15 years at Edifice Consultants Private Limited, leading regional operations and handling large scale projects for clients like TCS, MasterCard, Cisco, and Credit Suisse. For the past decade, he has led the NGK studio with his partner and wife, architect Nandini RG Kadam, driven by a strong belief in sensitive and sustainable design. The studio has worked with clients like Bajaj Auto, Microsoft, KSB, Elpro International Limited, Deepak Fertilizer and Petrochemicals Limited, creating contextually rooted high performance spaces. Beyond practice, architect Kadam is also a passionate mentor and educator, actively contributing to architectural dialogue in India and internationally. So, without further delay, let's welcome architect Rahul Kadam and get ready to explore how glass, when used intelligently, can help us shape safer, more sustainable futures. Welcome, architect Rahul.
Thank you, Yamini, for the introduction, and good evening to all of you. Um, Very happy to be part of Ethos in sharing some specialized work related to glass design. It's a very good initiative, I must say, you people are taking.
We are glad to have you on our webinar, sir. Um, you have had such a rich and diverse journey from working with some of India's most influential architects to leading large scale projects globally. I would like to ask you, how have these experiences shaped your approach to design today?
So, I think in my case, I must say I've been a little lucky because uh, right from the conceptual or strategic stage of the projects when I started my career, um, I was able to participate in specialized solutions where glass was being used. Then the entire process of how it was detailed out was understood under some of the mentors you named where I worked. And then, of course, uh, in those days, project management was not that regularized in India. It was very nascent. So architects had to do a lot of design management. So I got to oversee the execution of those technologies at site. So a lot of hands-on learning happened uh, because we used to spend almost 50% of our time at the design studio and at the site. And I think when you work at site, actually dirty your hands, you learn a lot. And I think those learnings of seeing the entire process have remained with me and I carry with them even today.
That's absolutely right, sir. That is something even today's new architects and students can definitely learn something and take up in their early practice. Another question that I had was, your work consistently blends sustainability with functionality, regardless of the project scale. How do you strike that balance between creating environmentally responsive design and meeting clients' demands?
Right. So I think for us at NGK, one of the most important things we've tried to do over the last 10 years is to have a culture a culture of sensitive design, sustainable design. And I think culture has been a guiding force for our commitment towards green design. Uh, because if there is no culture uh, as a philosophy, then things don't happen. And more often than not, we get invited for projects because of that culture. So clients who want projects done to be in a specific way, which I would say climate friendly, they come to us, they invite us. Whether that materializes into a live project or not is a matter of circumstance, but you are known because of the kind of work you believe in and the culture of the studio. So I think that is something which has always made us do whatever we do, and it's been a guiding force.
I'm sure that also makes work exciting and gets you come to office with more passion and more dedication to do more different kinds of work. I would also like to ask you, with a client list that spans major industries like tech, manufacturing, education, how does your design approach adapt to the unique needs of each sector while still staying true to NGK Studio's core values?
So contextual relevance is very important. Every sector, we've been fortunate to work with diverse clients, corporate, institutional clients, personalized clients. So obviously, in that diversity, the contextual relevance is also very important because each sector, each industry has its own sinews which you have to align to. And of course, there is a framework of the quality, the cost, and the timeline that one has to respect. So, as I said, coming and going is not important. It's what we leave behind, being the vision statement. Uh, it is at the backdrop of three core values, which we call it as the S to the power of uh, three principle, where uh, sensitivity, synergy, and sustainability. So these are the three core things we always try to imbibe in our work, and these, in a way, kind of give a holistic uh, approach to whatever we try to do. And you know, contrary to a lot of architects, where they feel that they have to be heard and the client has to listen to them, we've always looked at design as dialogue, not a monologue. So when you treat design as a dialogue, you with the client are working on common ground. The same thing extends when the consultants come in. The same thing extends when the collaborators come in. So when you treat design as a dialogue, then it starts becoming a teamwork. And I think these values have helped us create what we have created. It is a lot of hard work. It's not as simple as this. But uh, the if you don't have a set of values or principles that you follow as a firm, then you cannot lead a team. And the kind of projects we deal with, client is also a team member because there's a project management department or a real estate department with corporates or institutes who then works with you. You don't work with only one person. So these are some things which we have been imbibing when we do these kind of work. Almost all our work, but when it comes to glass, it's a very specialized case, and it has helped us.
I'm sure it must have taken a lot of years of experience and practice to finally come up to a system where everything just fits right in, and now it must have become much more smoother than what it was earlier.
It's never smooth. Every project has its own set of challenges. The biggest problem with glass is we have to wait for the first rainfall to be successful, not so that water doesn't come in. We've had projects where we have had near to cyclone wind speeds. In one project, in glass faced an earthquake. So every project has its own complexity and one set of challenges. So the homework before you start the project has to be very, very thorough, and you have to have a thorough understanding of the subject. Even though you are not the specialist structural engineer or the facade engineer doing it, your understanding of the subject in terms of fundamentals has to be very thorough. So before we even put up these kind of systems to clients, we have to do a lot of homework before we go to the meeting. So it's not formulaic. Every project has, it depends on, and you will see in the presentation there are uh, varied solutions given this situation.
That itself was going to be my next question about how glass plays a role in building for the future, especially as you mentioned in disaster preparedness, sustainability, while also maintaining aesthetics. So now that we have started, talking a little bit about glass and the projects, I would like to ask you your philosophy and design thinking about how your studio integrates performance, aesthetics, and high comfort through glass. You could also maybe share your screen and introduce us to the kind of projects that you have done
Yeah,
and how you took these decisions where glass became important in the projects.
right. So yeah, I think a lot of these questions that you have put up, we've tried to put a small presentation in place, which is having a case study approach, so that we are able to showcase to all of you uh, different situations of use of glass in a building, because essentially it's the envelope of the building. So as I will present to you the slides, you will get a more clearer picture. But before I go into presenting it, I just want to thank one of my team members, Tanaya Gule, who was involved in putting this presentation together, because we tried to take a broad spectrum of case studies and the related technical details. So I'll just share my screen, and then a lot of these points will be kind of addressed. So we have categorized our sharing in these four parts. In the first part, we'll talk about the context in relation to the built environment. Then we will talk about some glass canopies, skylights, and the building facade skills. Um, in terms of the context, if you look at the if you look at building, then the glass canopy is the one which kind of welcomes you inside. Then you have the building skin, which has got glass. We'll talk about some of the examples of that. And then, of course, to get light into inner areas, you have skylights. So these are the three types of glass surfaces usually a building has. And before we go into some case studies, I think it's very important to understand the design forces one has to consider. This is a holistic way of looking at any project where glass is involved, and we follow this process. So one is the creative aspect, where the visual or the wow feeling has to come in, because when you look at something that you've done, the visual appeal is very important. So the creative aspect is directly linked to the visual aspect. The technical aspect is the next part where the constructability of that glass solution with the structural engineer and obviously the facade consultants and the concerned contractors comes into play. And then, of course, is the functional aspect where the safety aspect comes in, because most of the buildings I'm going to show you are public buildings. So safety is paramount, whether it's an earthquake, whether it is a terrorist attack or a bomb blast, um, fire, safety plays a very important role. And then the uh, fourth aspect is the environmental design aspect, where buildings have to respond to the context in terms of their performance, in terms of the comfort, and glass is a direct enemy of sunlight. So in that light, is the uh, facade solution helping you to conserve energy or to consume more energy? So the performance of the facade is also very important. Let's look at some case studies, starting with uh, a glass canopy. This was a canopy we had designed. I was involved in a few years back for a hotel. This is 15 meters long by 7.5 meters wide. So it is got a proportion of x, 2x is to x, and it is 6 meters high. So obviously 6 meters, because if there's a fire, the fire brigade should be able to go below. But the whole idea is there are three such canopies to the entrance of the hotel to take in guests when there is heavy rain. So two cars can easily park and guests can come down. You can see in the section here. At the same time, when there is, people have to be received back or chauffeur driven back, the cars come in and they are received. So here, obviously, when you're doing a 5 meter by 15 meter installation, wind speed acts very negatively because it has got an uplift pressure on the edge of the canopy. It can completely make the canopy topple. So a series of tie rods have been used, which you can see here, and they are transferring the load of the canopy to the neutral axis of the beam here. And the tie rods are also used in a specific way so that on the side also the wind uplift is taken care of. But the material of the canopy itself is glass. So we've used a specialized laminated tempered glass, which is supported. So the section here is detailed out here. We have which are PU coated so that they don't rust with L clips, and on that we have two layers of 8 to 10 mm glass and a 1.5 mm laminated film, so that even if there is an earthquake, even if there is a bird attack or a terrorist attack and a bomb blast and if the building vibrates, the glass will not break. The laminated film will hold the glass. So the glass will never fall. A lot of people in public buildings die because of splinters of glass falling on their body. So laminated glass kind of avoids that. So this is the detail at this point at B, and at A, in between these ribs, we have loops which give rise to turnbuckles, and these turnbuckles then hold, give way to the tie rods which hold it at the neutral axis of the beam. This is where the beam is. All this is coordinated very carefully with the cladding pattern. So we have used giallo stone, which is 1 meter by half a meter, and in the pattern of the stone it has been integrated. So aesthetically it looks very crisp, as you can see here. And this is without anything, just to show you the entire canopy of how it looks very light. So there's a lot of things in there which are making the canopy work, but it doesn't look like an eyesore because it's all well integrated. Let's move to some skylights. So in the same hotel, there is a skylight done above the swimming pool. This is this the swimming pool is about, it's just an exercise pool, so it's 5 meters by 15 meters. And above the swimming pool, we have this skylight. The assembly to hold the glass is very similar to the canopy. The only difference being that there is a ridge line in the center and the water is drained off on either side. So there is a microscopically, there is a small ridge here which is draining the water on the side. On the side offsets, there are gutters. And then behind these columns, there are connections up there in the ceiling, which further divide the water 50-50%. So the water goes to the downtake pipes, which is in this casing, which you can't see. Again, a lot of safety considerations because this is on a middle floor of a building, and if the building were to vibrate in an earthquake, or if a bird was to drop, or if there was a terrorist attack, no glass should come on the swimming pool water. So a lot of testing and considerations in terms of the way the glass is sized and the way it is treated with laminated tempered glass was done. In public buildings, there are authorities which certify glass also, because unless, especially in five-star hotels like this, there is a third-party audit done so that one is absolutely sure of the provisions and the safety precautions. So this is just to show you the entire picture of that space and how the swimming pool is reflected into the skylight. Uh, on similar lines, but slightly different, this is a skylight done for a cafeteria we have designed. It's a very large cafeteria for 1,500 people. And right in the middle of the cafeteria, we realized that this was the situation. It was quite dark and dingy. And we had the average span was about 11 meters. So we decided to cut the slab and then cut skylights on the top. Each skylight is about 9.5 meters wide, but broken into three parts. We couldn't do away with these beams for structural, tying for earthquake, because the building needs a tie because it's 11 meters wide. And on top, there is a curved skylight with a grid system. And on top of that grid, we have curved glass at tangents. But here, contrary to the previous example, we have, side ventilators here, which allow all the hot air to escape out. And all the air conditioning in this building is using evaporative cooling. Evaporative cooling is very similar to a desert cooler. So it kind of kicks all the uh, cold air down and all the hot air is pushed out. So all this has been integrated in the skylight. And for birds not to fly in, we have bird mesh on the side. So here you can actually see the kind of light. In this project, we wanted nice trees into the cafeteria and actual grass, but the client was a bit skeptical about maintenance. But so we got artificial turf and pebbles, but it gives a beautiful feel of the light kind of filling up this space and making it very lively. Now we come to a little complicated solution. This is a dome. So this is a dome, which is almost 30 to 31 meters wide. And right in the center, there is an oculus done in laminated glass, where in the night, there's a hanging chandelier here, which is about 2 meters or 2.4 meters to be precise. And it becomes like a jewel in the night. But in the day, uh, what happens is this oculus brings in beautiful light with, again, two layers of 8 glass with a 1.5 uh, laminated film, and it kind of fills up this space with light. And the way it is designed is that this oculus exactly sits over the tiled surface of the dome, so that water doesn't go in. It's projecting out and all the water goes there. There is a fascia here and a slight air gap, so that again hot air kind of escapes out from there, and you have a good circulation of cold air below. So environmentally also that is being looked at, and then you've got this kind of beautiful aura of light coming down, as you can see here. And there are the changeover from afternoon to evening is signified by this nice pattern of the oculus being reflected. This is, I think, around at 12 o'clock. It gives a beautiful pattern of the oculus on this plane surface. This is another example of a skylight of a large workspace we have done. Unfortunately, this building could not be oriented the ideal way because of the way the site was. So the office, this is a plant office. It starts in the morning. So we decided to get in west light, because the office only works from 8 to 4 or 8 to 5. And the west sun would be then in only at 3:30. But in the morning, the west light is the best light. So we got the west light. So this is the west light coming into the office. And the central part of the office is literally flooded with landscape. So it becomes like a collaborative space where people could come out. And everybody here gets diffused light in the morning. And the east light was taken perpendicular to the working plane, so that you don't get glare on the screen. And it's a very nice place to work in. And the entire space is further uh, treated with cross ventilation and evaporative cooling with HVLS fans. And here you can see the detail. We have a 3-meter wide skylight, which is almost 45 meters long. And this 3 meters is further divided into 4 parts of 750 or 0.75 meters. So it's the same technology of laminated glass supported by these ribs. And to remove hot air, as you can see, the cold air is settled at a lower level, even by ventilation and cross ventilation. And all the hot air is removed from these louvers, which have a bird screen so that birds cannot fly in. And in a very passive way, we've been able to maintain very good comfort conditions, and we've reduced huge amount of air conditioning load in this space, almost 70% plus. So this is the space with the landscape, the workstations, the east light and the west light in the morning. So up to 334, it's very comfortable. And then to avoid direct glare, on top of the skylight, just to take you back, we have anti-glare film here. So it actually reduces solar radiation by almost 80%. Because on the west side, between 4 to 6 it can be hot, so we had to do that. But otherwise, I would say 80% of their work day they get good filtered light. We move to the kind of last category, that is the glass skin or the glass facade. So here we will show you a variety of skins, starting with structural glazing and why it is called structural glazing. So this is a sports bar we have designed in one of our sports and wellness centers. And here, unfortunately, the worst side climatically, east-west, had to face uh, the water and the view. And then you come into the sports bar after playing badminton or working out, and you have a drink. That was the concept. But the best view is on either side of the water. So there is heavy wind load that acts on the walls of the sports bar, which had to be transparent. This is the sketch that was done visualizing. We were very keen to do this in bamboo, but in spite of our best efforts, we failed. Client wanted something robust. So we had to go with a combination of steel, uh, aluminum, and glass. So the sports bar is around 4.4 meters by 11.2 meters. And in terms of the construction, there's heavy wind load. So beyond when glass, particularly structural glass, goes up by 2 meters height, it is subject to heavy wind load. So you use structural glazing, tougher tempered glass, which is kind of, just a minute. Yeah, which is capable of taking heavy wind loads because wind is directly acting on this. But then there is a sequence in which the glass is designed. So the first thing is that the glass is connected by, as you can see in detail A, spider clamps. These spider clamps actually hold the glass together. And at the top part, where the wind loads are higher, there is glass fin. So this makes sure that the thrust on the glass is taken care of. And then the spider clamps and the fins then are further connected to this structural ring beam. There's a ring beam below here also, which you don't see because it is below this pedestal. And then the load is transferred to the foundations. In this case, it was very complicated because there's water and then there is a pedestal and then there is foundation inside this. So we had to do a waterproof kind of foundation. So a lot of things which look beautiful have a lot of complexity involved. So for this to look this beautiful, a lot of anti-rust or anti-corrosive foundation detail is done inside this pedestal. And then, of course, very high wind speed that hits on this surface. Now, this is a slightly typical example where uh, we've designed the public areas and the office space of this building, including the facade. And the idea was that wherever you wait in the atrium, by the way, the dome that I showed you is of the same building. So this is just next to the dome. You are able to frame the view of the landscape. And here again, as you can see here in this diagram, the first beam is at 3.9 meters height here. You can see here. And then this span is about 6 meters, but it is in a reverse curve. So that is further building thrust like a bow or to some extent on the glass. So then we decided to, this size of glass was becoming very expensive and not viable. So we decided to uh, divide 3.9 meters into two parts of 1.95 each. And then each part was around 1.2 meters. So you got the proportion of glass in the golden ratio of 1.6 to 1.618. So it looks very beautiful. Otherwise, this proportion would not have looked nice. And then this is the proof of the pudding. As you see, very similar to the first case, the glass is connected with spider clamp. This is the top fin. And then the top fin further then gets connected to a plate which transfers the load to the uh, beam. There is a lower connector here also, which you can't see because it's behind the furniture, but there is a set of a plate and clamps here which transfer it to the ring beam there. So all these things that you do is done to capture the view because this is an air-conditioned space, but you have to be careful that safety-wise, all these precautions are in place. Again, I might sound like a broken record, but if there is an earthquake, the facade will move in all axes. And the glass is designed up to a certain tolerance, but till people escape out of the building, the glass should hold. This is the conventional, um, you know, what you call as glazing. So this you see very commonly on glass facades, curtain glazing. Uh, we've always used this on the north facade because it is glare free, and in this building also it's been done on the north facade. The system to do this, there are two systems. The best conventional system is that you have a set of vertical mullions and horizontal transoms, which are clipped to the beam. So for example, if this is a floor, there's a beam, this is one floor, so there's a beam here, and there's a beam here. So at this beam, this framework is clipped onto, and then wherever there is a panel of glass where the floor is, you have fixed and openable panels of glass. About 20% of the panels of the facade have to be openable in a air-conditioned building, because if there's a fire, you should be able to open the glass for the smoke to go out. So this could be fixed or openable panels, but where there is the beam should not be seen in the night. So there is something called as a spandrel panel, and the spandrel panel also has glass on it, so that you don't realize that there is a spandrel panel. So spandrel panel is nothing but insulation and glass, but it always comes at the beam level, and the junction between the spandrel panel and the beam is filled with intumescent, which is an expandable form of uh, kind of insulation. So if there's a fire, this will expand and not let the fire go to the next floor. So it is called as a fire seal. So that is done at this level. In this building, because we had a very structured column geometry existing, we treated the columns only as the mullions. One had the transoms at this axis and had large panels. And then we have so this is almost 3 meters wide, and we've broken this glass into two parts, which you can't see in this photograph, but there are at least 4 or 5 panels where we have two windows which open outward, pivot outward. So the window kind of pivots out. This system can also be used if you use double glaze systems. So in that case, the transom comes and then there's a clip and then the double glazing. This is the inner glass and the outer glass. The inner glass is always thinner, the outer glass is always thicker. I'll come to this in an actual solution we've done in the next few slides. So this is where you see the building. All this is north facade. Uh, and you can see the system here. Yeah, this is the solution where we use double glazed windows. Uh, these are 8 meter, um, 8, I'm sorry, there's an error here. It's 8 feet by 9 feet. So 2.4 meters by 2.75 meters. The whole idea is to frame uh, the landscape because we had beautiful mangroves outside, and this is a boardroom we've designed. So we wanted everybody to look at. So this is one piece of glass in 2.4 meters by 2.75 meters, 8 feet by 9 feet. And this cross section is somewhat like this. We have 10 thick glass outside, which is coated for anti-glare and heat, because this building did not have long chhajjas. It was an old building which we have repurposed. Then there is an air cavity of about 50 with argon gas so that the cavity becomes hermetically sealed. And then there is an inner glass, which is this glass, which you are seeing from inside, which is about 6 to 8 So this entire section is made in a factory, and it comes as a ready-made section and is brought and installed. So a lot of measurements at site have to be checked, not only physically, but with laser, and then the whole installation is brought. Because if this goes wrong, the entire window has to be rejected. So this cuts down heat as well as sound. In the case of boardroom, this boardroom was next to the mangrove was the old Bombay-Pune highway. So we had to achieve high decibel privacy inside, and which we were able to do by these windows, but at the same time frame a beautiful view. And inside here, there are pelmets which close these windows when you don't want the sun when you're doing a presentation. Like these kind of blinds are there inside here. This is just to show you the entire boardroom where you can, frame the view and get a beautiful natural light because of those. Of course, we couldn't do anything here because this is where the column is. So the column actually juts out that way, so we couldn't break the column. So column to column, it has been taken. We are also involved in doing projects where we want our facades to breathe like a living organism. And here is an example. This is a proposed high-rise where, unfortunately, the east-west axis was the longest axis of the building, and we had to safeguard it. So what we've done is the facade of the building is inside, and then we have a veranda space which is lowered with plants. This can be between 1.2 to 1.8 meter based on the FSI relaxations you get. So this kind of, and this is plants with running water, so it kind of keeps the whole area very cool. And then the glass facade, which, kind of becomes a boundary, and the office is inside. So here we've actually used displacement ventilation, which throws cold air from down and all the hot air removed from there. And because of this, we are able to save almost 12 to 15% of latent heat that would come from the facade. So this actually, that's why we're calling it as a breathing building, because it actually makes the building breathe. Similar kind of building has been designed by RMA architects Rahul Malhotra and his team in Hyderabad. I thought I should show you this case study where you have a service space and a veranda space where these green plants grow, and they also go outside the building. And the entire building is fed with a mist of drip irrigation so that the plants grow. And then inner facade is protected and it is cool. So this also reduces a lot of air conditioning load because this is not exposed. The inner facade is not exposed to direct sunlight. So this is just to show you the building, how it is a breathing building. Here all the public shade areas were non-air conditioned and the lower part of the building became a public realm, and the facade also kind of echoes the aspect of sustainability by having the lowered facade I showed you. With a terrace which is there to grow its own food and a solar hue which gives the building its power requirement. So with this, I end our sharing. I think our effort has always been to be very holistic, where the functional, technical, safety requirements, environmental requirements, and the aesthetical requirements kind of looked at very carefully, so that a memorable solution in glass is brought about. Because the glass today, whatever you say, it becomes the visual identity of the building. So it can make or break a building. And I think it's our responsibility as architects to make sure that we, bring all these design forces together and do a good job about it. So thank you. I think this is what I wanted to share.
This was definitely a very insightful presentation with lots of details. I'm sure our audience have got to learn so much from the entire presentation, because it not only focused on glass but also a lot of things that revolve around fixing glass and how the final product actually looks after following so many procedures and following so many systems that have to be in place. uh, I think I have a few questions that I would like to ask related to glass and the kind of processes and procedures that have been followed. Many of us admire the visual impact of glass in architecture, but it's not always obvious how early these decisions are made. At what stage in your design process do you start thinking about the role of glass, especially in terms of safety, climate, and visual experience starts?
So most of my career, whatever I showed you in, I think half an hour is 25 years of work and a lot of hair has gone lost in creating and building that. Uh, I have mainly worked a lot with corporate institutional clients, and even when I work with developers, they are corporate developers. I've worked, I must admit, not worked with the developer market, the, because that's how my career got built. So uh, definitely with all these kind of clients that I've worked with, um, we have always tried to use glass in a non-cosmetic way. Just it's not putting some makeup on the building. We've always looked at glass as a material which needs to be understood. The technology needs to be understood. And while we're doing that, how do you use glass in the correct directions? And why do you use glass? For what purpose do you? So just a good example of what I'm saying is the west skylight that I showed you in the plant office. So first, even I was a little skeptical that it will not work. But then when we went to the site and actually saw how harsh the east light is also, because it's a very open site, and the west light is very good in the morning. I said, why not use it? So I think concept stage is the right stage to start with. But then, of course, you know, If you miss the bus, as they say at the concept stage, you have the schematic stage uh, to make up for. But at no stage I would advocate that you should use glass in a cosmetic way. It has to be an integrated, holistic solution. So that's how we've been always looking at it. And sometimes when we try to tell this to clients, we have even lost projects. But that's how it is.
I'm sure it must have taken a lot of experiences to come up to this decision. I'd also like to ask you that some of the glass systems that you've used, like skylights or spider glazing, require close collaboration between designers, engineers, and vendors. How do you navigate this collaboration, and what should young architects keep in mind when working with performance based glass?
So yes, definitely you first have to be very clear what you want to do. Uh, I know architects from architecture school hate TOS or engineering as a subject, but it's one of the most important subjects in real life. So you have to work very closely with the structural engineer, the facade consultant, and the industry, which is obviously the specialized vendors. It's a very close way of working. So the first thing is your clarity of what you want the glass to do, whether it is a skylight, a skin, or canopy. The next step is your design intent has to be very clear for the structural engineer and the facade consultant to articulate that into a tangible design solution with you. Then, obviously, the structural engineer will see whether it works with the building in terms of the vertical loads, the horizontal loads, the wind loads, and will advise the facade consultant to take certain measures. Then the facade consultant and the concerned vendor will make, once they are on board, they will make the shop drawings or the manufacturing drawings, which you have to vet with them, given your original intent. And then, of course, if it's a very large installation which has got high risk, then mock-ups are done, which are like 1:1 scale study models. In some cases, the building is subjected to wind tunnel test also. So you have to make a model, and there are wind tunnel laboratories in which the model is tested, or a third party audit. Like we have done a canopy, which uh, it's not a facade, but it's a comparable example where it's 61 meters in length, and it was on a balanced cantilever principle, 30.5 and 30.5 meter on one support of 8 meters. So IIT Mumbai were a peer review consultants. So on paper, uh, whatever can be done to make sure that it is workable, it is safe, it is, and at the same time, it is giving the aesthetic thing needed and the performance from the environmental point of view is done as a team. So here, one of the players is also the environmental consultant because they will see the performance of the system. Uh, and in projects where this collaboration has not happened, I'm sorry to say you start getting an eyesore which dies its own death. So in the first 3 years, the building starts looking aged and dated because the thought has not gone in. So we have to work as a team. And of course, client is involved in every stage because for a large project, client has a very strong projects team. But principally, the people I mentioned are the collaborators who make it happen.
So, in colleges, we are often told to prioritize sustainability, but it's not always easy to connect it with material decisions. How do you define sustainability when it comes to choosing glass for your projects?
So sustainability, unfortunately, has become a very fashionable word. I also teach as a visiting faculty whenever, whichever semester allows me to teach, considering the workload of the practice. And I find that a very loose statement about sustainability, a fashionable word is used. Actually, it is a big responsibility and commitment. It's no longer an optional thing because as we talk, global temperatures are soaring and resources are depleting. And the building industry has a huge contribution in global warming. So we have to treat it like a responsible commitment. And I think as architects, it's our responsibility to educate clients uh, in telling them that our projects uh, should be responsive and should be holistically sustainable. So in our projects, uh, even if a project is not certified under the LEED Charter, we make a very serious attempt that it is between gold and platinum without even getting certification. Because then gold, platinum, platinum plus, these are all very rosy titles. I think what's more important is what is your building doing to them. And glass has a huge impact because if it is not used the right way, it's going to create a lot of imbalance. So I think the architects have to take the lead in that, and you can't treat it like a cosmetic layer, and it's a matter of convenience. And we've always believed that that's how we've been trying to tell our clients. Some are receptive, some are not. Those who are receptive, the project goes to the next level. Those who are not, the project doesn't happen. So there are both sides to it.
That's really very important. And I think that is something that even young architects and students should keep in mind, because while we are in college or when we are just starting out, there's not much knowledge or education about uh, these things. So I think this is really important to keep in mind as to the kind of responsibility that we hold up to what we are building, and how the designs should be. Following up on that, given that so many of your projects integrate glass for light, heat control, and security, how do you approach innovation in each new project? Is there a project where maybe you experimented something and learned something which was totally unexpected?
So, yes, learnings from the past projects always are looked at every time you approach a new project. Um, because sometimes, something works in a project so beautifully, then it starts becoming something which you want to do in every project because it's a tested devil. But there's the other side to it also that sometimes if there is a failure, then you are scared of using that. And many times the failure is also because the detailing and the research behind that was not correct. So one has to, at the end of every project, take a conscious view of what went right, what went wrong. We try to do a lessons learned approach in every project, but I would say our success rate has not been more than 60 to 70% because time is always the enemy. Because in the lessons learned, the client, the consultants, and everybody from the team has to come together to actually participate. So this is one way of lessons learned at the end of the project to see what we can take forward. But I think in terms of innovation, uh, the will to come up with something different, which is state of the art, and that is not different for the sake of, I think contextual response, I've been saying this, is very, very important, and you have to be very appropriate. So there is a whole strategy of how you educate your client because he's the patron of the project, and how the best solution that is best suited for the project is brought in place. And then that's where the innovation happens. So yeah, every time there's a new project, one goes through this cycle. Um, and yeah, the, sometimes it ends up in a losing situation because the client doesn't have that budget. You want to do something right, but client doesn't have the budget. Suddenly he said, hey, abhi paisa nahi hai. What do you do? And sometimes it ends up into a winning solution because the client is looking just not only budget, but is looking long term. So, but that's the beauty about it. I don't think projects we've not built, I think, are our best projects still. So you have to be hopeful. The next, like this breathing building, we've been trying this concept since the last 4, 5 years. Now, certainly people have started approaching us, and I'm very confident that maybe in the next 2, 3 years, a building will have that kind of facade. So, no research related to innovation goes waste. You have to be very optimistic. Norman Foster's one very interesting line is that you have to be an architect, you have to be an optimist. If you're not an optimist, you can't be an architect. So you have to be optimistic about what you are doing, and then things happen. You have to have patience.
Speaking about learning and educating ourselves, if you could give one piece of advice to students or young architects on working with glass in future ready architecture, what would that be?
So I would like to put my answer in two parts. One is obviously the way you approach. So right from the site analysis part, where you spend considerable amount of site at site to understand, whether your building needs glass or doesn't need glass or a hybrid system. And then obviously taking a holistic view about what you're going to propose um, in terms of the place, the context, and all that. Uh, but I think a lot of learning also happens by travel. I spend almost 15, 20 days of the year traveling to go and see some of the best work. Because when you travel, you see, you realize, you understand, you imbibe, and then you have to sketch, not write down notes and take photographs, but you have to sketch. So you should have a travel sketchbook with you. And I've seen a lot of things that you write down when you travel as notes or travel diaries. I think in one of the forums that of Ethos had presented my travel diaries as a part of sketching series. A lot of things remain with you because when you see, you analyze. When you analyze, you draw. When you draw, you understand. And when you understand, it kind of remains in. So there's a process that happens. And traveling has helped me a lot because when you go and observe work, you learn a lot. And then the third aspect I would definitely say is to be curious all the time. You cannot know everything, which is a good thing because what you don't know, you have to take support of the industry and collaborate or get mentored by people who know. But if you don't collaborate, you don't reach out to people, then how will you know? So we spend a lot of time in discussion with vendors at site, doing mock-ups, which are like 1:1 scale study, also understand the why behind the issue. And that I think comes out of the attitude of being curious and young all the time. Because if you're not, then you will never come up with a unique solution. So these are some things I would definitely advise students to do.
That's some really beautiful advice, sir. Thank you so much for that. With that, I think we come to the end of this webinar. I would like to thank you, sir, for sharing your time, insight, and years of experience with us today. The way you broke down the integration of high performance glass across aesthetics, functionality, and safety was not only enlightening, but also incredibly inspiring for everyone watching, especially the young minds just beginning their design journeys. On behalf of Glass Academy and Ethos Empowers, thank you once again for joining us and generously sharing your work and expertise. A big thank you as well to all our attendees for joining us today. We hope this session has sparked new ideas and opened up perspectives on designing for a more resilient, beautiful, and sustainable built environment. See you all in the next webinar.